No.
No,
Oh,
no. Okay, so Raspberry Pi, Cambridge University in England 10 years ago said, you know, most of the kids in the world can't afford a computer or a laptop. We got to do something. So they came up with a circuit board like the Arduino, only on steroids. It's a full-blown computer. It has the horsepower of an inexpensive laptop, only it's $35. $35. It has USB ports, it has an Ethernet port, it has wireless built in, there's a CPU, there's memory, everything you need, all the components, all the digital components for a full-blown system. But this is the part that I want you to see, all the pins. This is where you get to connect other digital components and other digital sensors. So it's a full-blown computer system. And by the way, that's a place where you plug in an HDMI port. That's the place where you plug in the power supply. It's the same power supply you'd use to power a cell phone, right? So this runs on the same amount of current and adapter that you would use to charge your cell phone. 35 bucks, hook it up to your big screen TV, connect a USB keyboard and mouse, and away you go. And you're browsing the internet, you're doing all sorts of things on the internet. It's 35 bucks. And I mean, it's a lot of horsepower for this thing. But everybody see this one right here?
yeah.
Yeah. So you want to talk about something on steroids. So here's a cluster, and it's a cluster hat. So the hat means it's an extension of, it's an expansion of the data bus, the pins, and then there are slots that you can plug in these other cards. So this is a way to like triple the capacity for this Raspberry Pi to do interesting and amazing things with digital devices. So you can tie those digital devices into a small computer. And yeah, so you see this little umbilical cord comes out of the USB, that's 5 volts, and it comes into the power supply of the daughter board, the hat that goes onto the, fits over the pins right here, squishes down onto those pins, and then there are other slots that you put the other cards in. This USB 5, this USB 5-volt connection powers all of these. It's very, very cool. So each of these might be 15, 20 bucks, depending on what you.
So you said the data card it's connected to the headers.
Yes, yes, they are. The pins, you might call that the header connections, right? This card, the hat, the base card, squishes down on top of this open board and connects along here. So now it looks like a sandwich. And then there are these other connectors here, the other ones fit into in order, right? I'm going to let you explore. And the more you submit for detail, the cooler it is, the more credits you'll get. Okay. Well, thank you for considering something interesting. I wanted to see if we could get more hands on this and just kind of kick the tires and see how rich this is lately. Every season they come out really cool stuff. This is around Christmas. They'll have even bigger and badder stuff this year than they did in the Popular Science November 2019 article. I think they're trying to get people to sit up and take notice. And at the very least I did. Okay. So what are we doing next? Well, I thought I could share this with you. Let's see. Let me get this out of the way real quick. Today is the 6th of November, right? Can everyone see my screen?
Yeah. See it?
Yes.
Okay. I'm going to do it like this, and then open it up in Word. I'm going to go landscape, narrow margins, copy and paste. Get a little better control over the size here. Oh, come on. It's plenty hard to get. There we are. For your solution, module for solution. What do you need to do to accomplish your module for solution? Well, we've said in your study guide that given a complex logic gate, design a complex logic gate using 3 or more different components that must include a NOR, a NAND, an XOR, or an XNOR. I wanted you to see an example of one option, okay? And whoops, this is my implementation view of what you have to do for your solution. So the student learning objective, the last student learning objective we just saw, is the primary objective of your solution. And that's going to be posted along with the optional assignment. And so you see the dotted line around here. I'm not showing you what the outer outline of this logic gate might look like, but this is the part that I had to draw with feeble hands. So there's supposed to be a curve here behind an OR shape. That's the XOR. So I labeled this. Does anyone know what this is right here?
A knot.
Yes, it is a knot. And it's not sitting in front of the OR, because if it was, that would be a NOR. We'd be looking at a NOR instead if the knot was sitting right here. But I wanted to apply the knot differentially to the input on the top of the OR. And then the B and C inputs, I wanted to, and there's supposed to be a dot with a fork here. I need to change that diagram. I'm going to go ahead and get my whiteboard and add the dot. So it forks. The C input runs into the lower XOR input, but it also forks down and runs over and into the lower input of the AND. So I have a NOT, an XOR, an OR, and an AND. I have at least 3 different logic gates, one of which is an XOR. That is what your solution requires. I can label this W1. I can label this W2. I can label this W3. I don't have to label this because it's a fork. So that's going to be the B bottom input of the XOR, and it's going to fork or split down here and become the internal B input of the AND over here. So output, larger output C is equal to B over here. Does everybody follow what I'm saying when I talk through that?
Not really. Me.
Okay.
May you want go try again, please?
Okay. So just to walk through how this diagram is drawn, I have 3 main inputs, A, B, and C, and a single output. The first input A hits the input of a NOT, and the out of the NOT is W1. And that flows into the upper input of OR over here, which we would call the A input or internal A input of OR. I have a large outer input called B, capital B, and that flows into the A input, the top input of an XOR. Now this diagram here with the curvy swoop, and then the OR in front is actually an XOR, only I'm not as good an artist. And so this B input comes in. The C input is forked. It doesn't show here, but the C input, there's supposed to be a dot there and then a line down. I'm going to fix that and then repost this. But I will post this diagram online in the solution assignment as a reference. And what happens with the C input is that it flows into the bottom input of OR. We call that the internal B input of XOR, right? That's what I meant to say, XOR. And it also splits and is the bottom input of AND. So altogether, I have wire 1 coming out of the NOT. I have wire 2 coming out of the XOR. I have wire 3 coming out of the OR. I have C coming into B down here. So I'll have 3 W or wires that I have to include in my HDL. So I'll go ahead and update this and then put it out there. But I just wanted to give you some ideas of what you need to do to satisfy the requirement for solution for the module for solution. You have to draw your own unique one. And you could use this as a model. You could just modify it. You could switch some of the components around. You could organize them differently if you wanted to. Or you could come up with something completely different and tell yourself, I don't want to use an XOR, I want to use an XNOR. Or I don't want to use an AND, I want to use ORs with NOTs. And I just want to mix up a bunch of ORs with NOTs, and I'll throw a NAND on the other end just to be crazy, right? So you may decide to do this totally different, but you're welcome to modify what I have here so long as it isn't identical exactly with what I have here. Okay, does that help? Does the additional explanation help, LaQuinn?
Yes.
Okay, all right. Any other questions about our diagram for the solution? Okay. All right, so what do we do next? What we're going to do next is I'm going to stop sharing the screen, and I will ask others to share the screens that they have so that we can spend some time helping students with the 4.1 assignment so that you have something due by then. I did want to take a little bit of time to call this out once more. Remember, we want you to watch these videos because there are going to be questions in the assessment from these videos. Okay? Does everybody get that? Nobody's going to be surprised or shocked or?
Yeah, I got it.
Okay.
I have a question on the, so on assignment 4.1, we're supposed to make our own diagram, or is that for a future assignment?
Oh, no, for assignment 4.1, I'm glad you asked that. So if you missed class on Wednesday, we showed everyone this, which should look familiar.
Yeah.
Logic gate E from the midterm, right? And we walked through how the logic actions, how the computing actions play out as you trace in the inputs with a truth table. So we have a 3-input truth table, 8 possible combinations, and we walked through it in class and actually gave you the truth table, which I've included here. So this is the truth table of the same diagram we walked through on Tuesday and Wednesday in class. And what we discovered was that the B and C inputs, if they're both true, or the A and B inputs, if they're both true, will result in a true output. Put another way, if adjacent inputs in the diagram, are, where are we? Oh, come on now. Trying to find my stuff here. If adjacent inputs are true, then the output is true. So if A and B are true, even if C is false, the output is true. If B and C are true, then the output is true. But if you put a false in here, if you have a true, false, true, then it's every other combination is false, with the exception of A, B, and C being true. So we walked through the truth table. We also gave you, on Wednesday, a starter HDL file. And we want you to build gate E as an assignment. And this is not correct down here, but the rest of it is in place. And you just have to customize your own stuff. So we actually gave you all the pieces to go ahead and complete this assignment. It is due, when is it due? It is due Saturday, tomorrow, 11:59 p.m. And what you have to do is have the HDL screen showing a true output with adjacent ones, either A, B, or BC, and ensure the third output is 0. So A and B is 1, that means C is 0, or B and C is 1, and A is 0. And then you also have to use another false output for a second screenshot, which I would advise you would use A is true, B is false, C is true, because that shows that the logic gate is working properly, because the false, the two trues for the inputs are not adjacent. There's a false in the middle, right? So when I say adjacent, I mean next to each other. True and true are next to each other. If A is true and B is true, they're next to each other. They're what we would call adjacent. Okay. But if we have true, false,
So what you were
true, yeah, go ahead.
so what you were showing on the screen before was for a different assignment coming up, or the because
Yeah, okay. So the screen I was showing before, this screen,
yeah.
that's the solution that is going to be posted under the optional. So what am I saying?
Oh, okay.
So just to be specific, inside module 4, you have your assignment 4.1 that's due 11:59 p.m. Saturday. You're going to have optional assignment 4.2 underneath here, okay?
Mm-hmm.
Which is what we were just talking about, the popular science thing, right?
Yeah.
And then you'll have solution 4.3, which is going to be worth 5 points. And what is that? It is the last student learning objective in our module study guide, right? So you're supposed to, we want you to get better and stronger at HDL and at drawing diagrams and at coming up with logic and discerning the canonicals, right? We want you to practice that a few more rounds with each module. When we get to the last module, we're not going to have time to do any more of that because we'll be talking about cool stuff like how to build your own PC for $300. And it's twice as powerful as a $1,200 MacBook Pro. That's what we're going to be doing in the last module. The last module is just plain jazzy. I mean, it's my favorite module. It's like, okay, when you put all this stuff together, what does it do? Oh, you can get it to sit up and bark. It's amazing, right? So we're gonna right before Christmas, we're gonna devote our time to the wonderful universe of computer components and where that's going, and that to me is a very fun module. But until then, we have module 4, and we have to be finished with module 4 by Tuesday. So you have an assessment that will also be due, your first attempt at module 4 assessment. That's why you don't have as many student learning objectives, right? So we had this brief introduction about physical materials and then which components you have to know, the digital components you have to know forwards, backwards, and inside out. Does that help explain everything?
Yes. Thank you.
You're quite welcome. Does anyone else have any questions before we share screens then? Anyone else?
Will you explain the HTML section a bit more in depth? I'm having trouble with that.
Yes, I will
For
be happy
the
to.
4.1 assessment.
The 4.1 assessment, okay. So you have this truth table that we did in class together based on this diagram, which was inside here, yeah? So this is the diagram that comes with the 4.1 assessment, and this is the truth table that we did together. Whoops, where is it again? There. I have the truth table, right? And the assignment is to come up with the HDL. Now I could have said your assignment, you have to come up with the canonicals, but that's no fun, right? What we want you to do is to take this diagram and this truth table and come up with your own HDL. Put it in your hardware simulator and run it. So I gave you starter text all you have to do is drag and drop this and copy it into, you right click and copy it into Notepad, right? And it's a text file, but you save it with a .hdl. You're going to put it into your, just like we did with the solution before, you're going to put it into your NAND to Tetris folder under Tools, under Built-in Chips. That's where you're going to store your logic, your HDL file. Okay, and that's the sample, right? So here's the sample in a text file. So I would save this as, I'm going to call this Newgate E or something like that, right? Or TK gate E, right? So based on this diagram, I mean, take a look. The first and in the diagram, you have A to A, B to B, and out is W1. What are we talking about? We are talking about this. This is the first and. That's the internal little a input, the internal little b input. That's the big A coming in from the outside, right? So when I have that HDL logic statement for the first and that's listed, I'm talking about this gate. The out is going to be my W1 right here. That's as far as I took the sample. So Schneider, you have to do the OR, the AND, the OR. So what do I mean? This OR, this AND. I guess this would be the next AND. So one of the things we'd want to do is change the order. When you're doing your HDL, I don't know if you noticed this, but follow with me on the diagram, okay? We have the first AND. That's this AND. It's already done for you. A equals A, B equals B, right? Here's OR. That's correct, except I didn't do it for you. We could do it together. So I could follow by saying, okay, what goes into this OR? Well, it's not A and B, right? It's B.
A equals B,
Correct.
B equals C,
Correct.
and the out equals W2 or wire 2.
Exactly. Yeah, you got it. So then you'd have a third AND. Okay, you got to do the same thing with the third AND. Except in my HDL, what I should have done is listed the third AND before the last OR, just to be consistent. So that's what I'm going to do now. I'm going to help you with this. And you can do the same with yours, right? You can do the same right now with yours. So we have an and, an or, an and the last one is the or. We have an and, an or, an and the last one is an or. So everybody see what I was doing there?
Yeah, like to be honest, I
Okay.
didn't really get. I don't really know how you got the OR section.
Okay. How we got the which or section? The first or section?
Yeah, the fourth OR.
Okay. I'll tell you what. Give me 1 second here. 1 second. I'll stop sharing for just 1 second. Okay. So let's share the screen again. So this or, yeah? In your HDL, the internal input for the top is called little a and little b. Do you understand that? It's this, little a and little b. Now the template that I gave you to work with, that you could copy and paste, I just put in placeholders for the other inputs. To make it easier to understand, you could say big A here and big B. And we could say big A here, big B and big C, just so we're consistent, okay? Because sometimes this case sensitivity is a problem. So I'm going to say that the big A here is the big A here, right? And so the big A is the input for AND on the top, and the big B is the input for AND on the bottom, right? When you get down to OR, the little a for OR and the little b for OR is actually the big B and the big C. So we're going to put big B and big C. Does that make sense?
I think so.
What do we do with
Yeah.
this? What do we do with that? Can you come straight out of this OR to the out here?
No.
Yeah,
Gotta
no.
go through another AND.
Well, it's going through another AND, but we had a W1 to receive the output. So we have a W1 here. What should this be?
Yeah, that's the W2.
Exactly. So now you know what to put. W2. I'm going to let you do the rest, okay?
Okay.
Okay. Why don't you do the rest while we're talking and sharing screens with other students, and then you could share your screen and ask me to check it.
Okay.
Okay? And
All right.
so this would be a W3, yeah?
Yeah.
This would be a W4. So, you know,
Yeah.
you just got to keep those things in mind. Would anyone care to share their screen?
Yes.
Okay.
Okay, should I share the HDL file?
Yeah.
Is the one HDL simulator or
You
the file?
You can share the file and then you can open the simulator.
Okay.
Let's look at the file first. Okay. Okay. Yeah, the logic up here is really good, LeQuinn. The way you stated your logic is flawless. Okay. Instead of using and, I would use or. Okay.
For what? Or for.
Yeah. See where it says and, I would use or instead. Because those are cases where it's true. And if you put and, it means all of those cases have to be the case in order to be true. Yeah, that was the only thing. But otherwise, it's flawless, right? Okay, so the only tricky part is toward the bottom because we just reversed the order for the OR. But you have W1 going into the OR. So let's look at the diagram. Let me look at the diagram again. You have W1 going into the OR. Is that the final OR? W1 is going into the final OR, I think.
Yes. Yes.
And yeah, so W1 is going out of and then W1 is going into the A, and W4 is going into B, and out equals out. So the OR looks good, yeah? And the AND, C input for A, B input for B. Yeah, I think that's right. I mean, they might be reversed, but I think they were reversed because of the way the wiring was. So I think that's right. Now I'm just going from what you have. Everybody's going to have a different solution. Everybody's just going to look similar but slightly different, okay? So and last and equals W2 So the W2 goes into the third and. Let me look. W1, W2 goes, oh yeah, it does. Yeah, no, that's right. That's right. It goes into the A of the third and. So did you run it in the simulator?
Yes, last night.
And what happened? You want to run it?
Come out the one saying, let me pull it up.
Okay, it does work or it doesn't work? Yeah. So if you stop sharing and then reshare after you have your HDL simulator open, then there we go.
Okay, let me run it.
Okay, so let's test it for a true condition. This is easy. Change the A and the B to 1, but leave the C 0. And then run it. And we should get a true. Oh, we get a true.
Yes.
Wow, that's good. All right, so let's check the other case. Make the C 1 and the A 0. Yeah. Oh, that's a 1. Now, here's the acid test. Let's make the trues so they're not adjacent. Make the A1 and the B0. Run it again. It should flip to 0. It does!
Yes.
Goal, goal, goal. Excellent. Outstanding. You're done, dude. You can submit this just the way it is. Nice work. Nice work. Okay.
Yeah, thanks.
Yeah, good job. Anybody else? Anybody else want to share a screen? Let's untangle any knots. If you're working this up, let's get it done. Sometimes you get really tricky scenarios where it's not working because there's an extra space, or it's case sensitive, or it's the way you worded, it's the way you labeled your HDL file. So sometimes if you're having issues and it's not really working, it's something tricky, and it's not the code, it's not the statements. And that's why we wanted to give people opportunities to share their screens today. Do we have any other folks that would like to share their screen? Any volunteers? Well, hearing none, we are getting close to 2 o'clock, and there may be other classes that other students need to engage. So that was what we had planned to cover for today. And I hope you all have a safe and pleasant weekend, and we'll see you Monday. Now, I do want you to know that I'm going to post the solution this afternoon. And when I say I'm posting the solution, I'm talking about the one where you create your own drawing. And in the time remaining, if anybody wants to draw, like just spitball something quick, you can email me, or you can share a screen now if you'd like for a drawing. We still have like 6 minutes left until 2 o'clock sharp. So, but I'll leave that to you. Does anyone want to care to draw something real quick and then share a screen? And how would you do that if you were doing it on paper? Well, you could join the session with your smartphone and then share your screen on the smartphone and hold your smartphone over your drawing. Does everybody understand what I'm saying? It's awfully quiet out there.
Yes, we understand what you're saying.
You're still gonna look at mine, right?
All right, let's take a look. Thank you, Snyder. All right. Hey, if the rest of you are ready to clear and start your weekend, have a great weekend. If you want to stick around and go over a screen, stick around with Schneider, and I'll still be here to help with the screens. Okay.
Let's see.
Have a great weekend.
Yes. Have a great
Yeah,
one.
you too.
All right, all right, Dr. Kent. Have a good weekend.
Yes, you too. Take care, Liquin.
Yeah, do you see it?
I do. So one thing you ought to do first, and let's just make sure we get this right. I always like the top-down approach, yeah?
Yeah.
So in the 5th line where it says created by T. Kentop, you don't want that there.
So erase it.
Delete the whole line. And then
Okay.
change where it says edited, put created. Okay?
Okay.
Yeah. There we go. There we go. And then don't forget, after we get the pins working down below under the parts section, you still want to create your logic, yes?
Okay.
So your logic comment, if, you're going to replace if with out equals 1 if, out equals 1 if,
If.
yeah, and then you have the 3 cases, and then it says else out equals 0. That's what you're doing. Does that make sense? Okay. And you don't have to do the logic right here. Let's focus on the yeah, else out equals 0. So you can do that, yeah. Just as a placeholder. But remember to complete the other, right?
Okay.
Okay. So let's look at your third and.
Yeah.
So the third and is C and B, that's reversed. Out is W3. That looks correct. Yeah, that looks correct. Let's look at the or. Well, let's look at the third and. The last and. You have to get the last and finished before we can do the final or.
Last and.
The last and. So what we're saying is the last and comes before the last or. So just to keep this straight,
Yeah.
I would switch the order of the last or and the last and. What do you think, Luke? Lance, does that make sense? Because of the way
Yeah.
the diagram is built, right?
Yeah,
Okay.
switch them around.
Yeah, that last or is, since or is the last, very last component, you want that listed last. And if it isn't, then it can get confusing. It'll still run just like LeQuin's did, but you're just going to copy and paste that whole line and then put it below. Okay. Yeah, let's get rid of the blank line there. Yeah. Okay, good.
Yeah.
So you have the first and is good. The first or is good. The second and is good, I think. Well, let's look at the diagram real quick.
Yeah.
Second and, yeah, is W3. That's correct. And it is C into A and B into A. So that's good. Yeah. Yeah, you have it. So the third and is correct. The fourth and. So let's look at the diagram. Can you share do you have the diagram up? You want me to share it?
I have the diagram.
You have the diagram? All right, so share the diagram real quick. Let's look at that third and.
So you see this, right?
Yeah, I do.
Hmm.
So the first and has a W1. The first or has a W2. The third and has a W3. The fourth and has a W4. And it's the or W1 that goes into the A.
Oh, so this supposed to be W4 then?
Yes. And the A input for the and is the W2 of the or, right? Look at the diagram. The or is sitting right there. So it's, you see what I'm saying?
Yeah. Yeah, I think so.
W2, yeah, that's it. And then the second input for that third and is actually the output of the second and the output of the second and is
Is W3, right?
W3, that's right. Yeah, that's it. And then your final or, the A input of the last or is what? It's the top line. What is that?
Be like W1?
It is. Good. Excellent. It is W1.
W1 and W4?
Well, yeah, it is. It's W4. You nailed it. Now, you're not going to use W5 because W5 means you're connecting to yet another logic gate. It's just going out at that point. So out equals out.
So how do you count?
Yeah. Okay, so let's save that and let's try to run it, and then you can circle back and finish the logic before you submit. Yeah?
Okay.
Okay. So you can share your hardware simulator?
I got it right here. So do I need to close this first? Or can I leave it open?
You can leave it open. So you're going to go to the file load chip. Yeah. Gate E. That's a pretty sight when it comes up like that. Don't see any red. Let's change. Let's change
And
it.
when I first tried to pull it up last night, it didn't work so well.
Oh yeah. That's what makes this interesting. But if you figure out how to do this, I mean, Intel pays people $100,000 a year to work with chips, and this is what they're doing,
I
right?
think I'm getting it.
Yeah. So let's change input value for A to 1. And then,
1.
yeah. And then let's change the input value for B to 1. And then you have to hit enter. Otherwise it won't take. There you go. Now run it. Double arrow to the right. Double blue to the right. Yeah, run it. Yes. Okay, change A to 0 and C to 1. And see if the two adjacent B and C inputs.
All right.
You might have to hit enter there.
Yeah.
All right. It's still 1. Very good. Now let's swap the values for A and B. Make A 1 and B 0.
A1, B0.
Yeah. Should flip to false. If the logic's working. Survey says,
Yeah.
yes. All you got to do is mop up the logic and you're done. You're golden. Okay,
Yeah.
so submit the 2 screenshots, right? So this is one of the screenshots, and then the other screenshot would be A and B equals 1, C is 0, or A is equal to 0, B and C are equal to 1. Yeah, I like the internal pins. It shows the W values, so you can follow the logic. With your diagram, you have to troubleshoot.
Tell me which one I need to take screenshots again.
So this is the hardware simulator that you're seeing right now would be one of the screenshots once you get your logic statement finished.
Okay.
And then you would just reverse the values of A and B again, run it, and when it flips back to 1, take that screenshot.
All right.
Okay?
So I'm gonna do A and B both as 1, C as 0. Then A as 1, B as 0, and C as 1.
Correct.
All right.
There you
Just
go.
making sure.
No, you got it. Good job.
Yeah.
Luke, what you got?
So
I
it's gonna be.
got mine to run.
So like, how would I write the logic though?
Well, okay, so out equals 1 if, and then put a curly bracket. Left curly bracket.
If
A
equals 1,
equal 1.
A equal 1,
Yeah. Yeah. Comma.
comma,
B equal 1. Comma.
comma.
Well, and
C.
actually, you could just leave C off if you wanted to be short, because whether C is 1 or C is 0, when A and B are 1, it's true. So you can put a right curly bracket after that, and it would be correct. You would not have to include the C value because the C value is irrelevant when A and B are 1. The same as, and then say, or, dot, dot, dot.
Yeah, or dot dot dot.
And then start a new line and say, left curly bracket, B equals 1, C equals 1. Or, actually, you could just leave it at that. Because when A, B, and C are 1, the first case that you just stated is also covered.
C equal 1, A equal 1.
B equals 1, C equals 1. You can state the third case on your truth table explicitly. You can say, or A equals 1, B equals 1, C equals 1. But in terms of pure logic, the first statement actually covers the last case, because it doesn't matter if C is 0 or C is 1, so long as A and B are 1. Does that make sense?
Okay.
So yeah, you got it now. If you just save the file the way it is, and then there you go.